All right, so now we're going to talk about ray optics. Okay, so this is treating light as a ray. Whenever you're thinking about light, you have to model it. Like I said in the last video, you can't really see what light looks like. And so now we're going to model it as a ray. And so the way you can picture this is, say you turn on a light. You can imagine just millions and millions of individual light rays hitting you. And this is a really helpful way to look at light when you're studying optics. And optics specifically is kind of how lenses, mirrors, the different types of lenses, mirrors work in different applications like eyeglasses, telescopes, projector screens, microscopes, things like that. So let's talk a little bit about some different things. So first we talk about reflection. Okay, you guys deal with this every day. You look in a mirror and you are looking at a reflection of yourself. The light comes off of you, strikes the mirror, bounces off of the mirror, so that somebody standing over here could see you as well. But also, if that mirror is nice and flat, you can actually see a virtual image of yourself in the mirror. So reflection is fairly simple. It bounces off at the same angle that it comes in. Then you have what more goes with lenses, and that is refraction. So light will go through objects as well, transparent objects such as lenses. You can see here glass, any kind of plastic. Refraction is something that you've probably seen quite a bit of. So over here, I've got a demonstration of refraction. You can see, I'll turn the light on here. And first little deal here is we will put where you can see one beam. You see that beam? And if you look, if I shine the light right through it, you can just see the beam going straight through. But if I angle the light, you can see part of that beam starting to refract. So see, it comes in, the light comes in, and it bends. And this bending happens because the light slows down in the medium. It causes this bending effect that you see. You can see it definitely bent. And you can do it even more. Part of this beam is traveling on top of it as well, but what actually gets in there, you can see bends. And this is refraction. Okay, it enters a medium other than what it started in, which it started in air, and then it gets into this plexiglass. And it only really happens if the light comes in at an angle. You can see here, no angle, no bend. Okay, so now where would that come in handy? Well, if you think about glasses, things of that nature, lenses come in play. Okay, if you have glasses, if you wear glasses, we're going to look at why and how they actually work. So lenses are curved pieces of glass. They were actually invented a really, really long time ago, in the 1600s or earlier even. But people talk about Ben Franklin inventing bifocals, so he was around 1700s or so. But before that, there were telescopes that were made with lenses already. And so lenses are curved pieces of glass, and they're used in all sorts of different things. This is not working so well. This here is a convex lens, which we're going to study today, and this is a concave lens, which you will see as well. So here's the two types of lenses. You have convex, thick in the center. We're going to use a biconvex lens. So it's thick in the center, thin at the edges. And this bends light a certain way, depending on what you need it for. And then you have concave, which kind of like it says, caves in towards the center. So you got thick at the edges, thin in the centers. Okay, so we're going to look at what it actually does with a ray of light. Okay, so every lens has what's known as a focal length, and that is based upon how much it actually bends the light. Okay, so if you're wearing glasses right now, the odds are actually pretty good that you don't have this type of lens. Typically that would be old people. But these convex lenses, they take beams of light, rays of light, and they focus it to a point. This is known as the focal point. The other type of lens, concave lenses, they diverge the light. So don't focus it in one point on the opposite side. Now you can use the reflected rays to figure out where its focal, how long its focal length is too. But they tend to spread the light out. So let's look at these under our device here. I'll do 3 rays of light. Here is your convex lens. You can see the light comes in straight and it bends as it comes in, and they all focus to a point. So the focal length of this would be, what is that, roughly 4 or 5 inches. Okay, so that would be a convex lens. Concave lens, you could see it diverges the light. So the light comes in and it diverges. You cannot see the reflected rays to make the focal point, but it'd be somewhere in here. Okay, so the different lenses determine what it is going to do. So over here, I've got the different lenses. This is a convex lens. This is a convex lens. This is a concave lens. If you look at it, you could see, if you look closely, you can see how this goes out and this comes in. Now, the way you could tell what your glasses are is you would look through it. If everything through it looks small, then you have a convex lens. Okay? Because when you look through these, the image is fairly distorted, and you'll see why in a second. But if you look through a concave lens, everything looks small. So if you have glasses on right now, you can take them off and see what you have. And I bet towards the end of this we can tell you why, or what type of vision issue you have and why you can fix it. All right, so now I'm gonna shut this light down. We're gonna take the light from the screen, or sorry, from the window, and we're gonna try to find the focal length of this lens. So in any convex lens, you can see this is the image from the screen, or from the window. You can actually see the tree in the background, but it only forms at a certain spot. So if I'm too far, you can't see it. Too close, can't see it. Forms perfect right there. In fact, you can see the swaying of the trees. So in that spot, I'm at about 10 centimeters. From the lens to here, it's about 10 centimeters. So that's the focal length of this lens. Okay? And it will form images. Take this candle now. If I get a certain distance away from it, so the focal length was at 10, so if I go, say, way over 20, I'll go 30 centimeters away. If you notice, it will form images based on when the light starts at. Look at that image of the candle flame. Notice it's flipped over. So it's inverted and it's a lot smaller than the original size of the flame that's creating the image. All right, now, if I get right at 20, don't touch hot wax, then let's scoot this back a little bit to get it nice and clear. Oh, sorry, here's 20 right here. There we go. Let's scoot this back to get it nice and clear, but you can see it right there. Here, it actually forms around the same distance, and you have a bigger image. Or sorry, well, it's about the same size. It's really hard to tell. And then if I come in a little bit, get between the focal length, you'll notice it gets bigger. I've got to... It's forming on my screen there. Let's try this. We can get it real close. And maybe project it on the wall. Can you see the flame now on the wall? Notice it's much, much bigger. Okay, or maybe even, there we go, that's a little bit clearer. And so it forms these images depending on how far away from the lens it is and what the focal length of the lens is. You can see it there on the wall. Okay, so depending on the type of lens and what its focal length is, will determine where it forms images. Now, so what type of images were those? So with a convex lens, you can actually form images on a screen. Okay, so you saw a real image there that was formed on that screen with the candle flame. This is a similar thing. Here they have an arrow, you can't really see it on the back, pointing down, and it flips the image. That is a real image, one that can be formed on a screen. And for these types of lenses, it's always inverted every time. And then you have the virtual images, which are formed on the same side of the lens. So basically a virtual image is if you're looking through a lens, you're looking at a virtual image. And so the concave lenses always form virtual images. And the convex lenses will form virtual images if you get close enough to whatever you're looking at. So magnifying glass would be an application. All right, so let's say if you've got something wrong with your eyes. You've got to picture the idea of an eye is it uses a lens, a squishy lens, and this lens in your eye has these muscles on either side, and it squishes as you try to look. If you look around at things that are close, and then you move there, and you move back looking further, it constantly flexes this. And what that does is change the focal length of the lens. So whereas my lens was the same focal length the whole time, your lens in your eye will change, so it'll bulge out the center more or spread it out more depending on how far away you're trying to focus on things. As you get older, your lens becomes less malleable, okay? And so vision issues tend to come and play as you get older. Of course, some of you guys are less than 18 years old, and you're like, wait, I'm wearing glasses too. So your eye is always producing a real inverted reduced image on the back. Okay, it wants to form this image on your retina. So the light comes in and it forms on your retina. Now what if you have a vision problem? Well, that means it's not really forming on your retina anymore. Okay, the light comes in and it may form a little bit too far in front, or it may form a little bit too far behind. You could see this person would be nearsighted. They see things up close, but up far away is hard. This person would be farsighted. They see things far away, but not so well near. The odds are pretty good that if you're a young person, your issue is that you can see close, but you cannot see far. All right, so nearsightedness. Okay, nearsightedness means you can see things that are near. So far away images are hard to focus. The reason this happens is that your image is forming too far in front of the retina. So the image needs to form here, like you saw on my image screen. It had to be in the exact right spot. But your eye is not able to move itself enough to form the image where it needs to be, and so you see blurriness. So it's hard for you to see far away. Near, you can see things that are close. Okay, so you would be nearsighted. So the way you fix it is you put a concave lens. It kind of spreads the rays out before they hit your eye and focuses on your retina. The type of lens that you have, how thick it is in different spots, how it's made. The reason you go to the eye doctor is all about where it forms here. Okay, if it's way up here, you're going to need a different lens than if it forms maybe right here. Okay, you don't have as bad of a problem, so you just need a really small lens, depending on what you're doing. And then you have the other type of issues, farsighted. Farsighted people can see far away just fine. The image forms behind their retina though. So notice it's got to form right here. And if it forms back here, then it's no good. Okay, so the clear up images are hard to focus, and a convex lens will correct the problem. If you have a grandparent that has glasses, if you go take her glasses from her, make sure you give them back, you will probably notice that if you hold your glasses and hers up, you can see through your glasses, things will look small. So you have a concave lens in your glasses. Most older people will have a convex lens to fix the problem. It's also why you see older people, if they can't read, they'll hold things out like this because they are farsighted, which means they can see things far away. And so they'll hold things out like that to try to read it. You probably notice it whenever you're, at your grandparents' house. So next time you want to play around with lenses, these are the different types. Hopefully you learned a little bit about how all this works. All right, till next time.